Hey everyone, Chang here. This is the practice problem video series. For today's standard test question, we have this problem right here. Which point or points must be removed from the following to be a function? Now, this is one of those test questions that basically see if you understand the definition of what it's asking. That's all it is. There's no complicated math. There's no let me brute force this and hopefully find the answer. It's either you know it or you don't. And well, guys can guess, what they want you to know is what it takes to be a function. Now, from our experience, a lot of the experience with function is f of x equals some equation. And it has problems ranging from here's what x is, find out what f of x is, or manipulate f of x to become something. This one is slightly different. There's no real f of x equals some equation. There's no equation. It's just a set of points. So, it relies on the definition. Well, the definition of a function is not an equation in any way. It's basically a set of rules that meet only one requirement. The requirement is that for every input, everything you put in, there's exactly one output. So that whatever you put in, you know exactly what you're getting out. So the best way for this point is to figure out, well, every time I put in, usually your input is x, right? So the x coordinate, it produces a specific y coordinate, or in this case, f of x coordinate, right? What we can do in this case is just to write it all out and then map them and see where they go. Well, let's see. We have 3, 2, 2, 4. Well, let me just put x, and then some of you guys might be comfortable with y, but I would prefer you just write f of x. That's just the name of the function, and usually as implying the output of it. So we have 3. When you put in 3, you get 2. When you put in 2, you get 4. When you put in 1, you get 3. When you put in 7, you get 1. When you put in 2, you get 3, right? So the question is, which of the following points, or like one or more points, that we must remove to make this a function? Remember, every input has to have a specific output. So whatever I put in, I have to know exactly what's going to come out. Well, if I put in 3, we know that's going to be 3. Great. If I put in 2, it's going to be 4. But here's the thing. We also have this one. If you put in 2, it's 3 as well. So if I erase this 2 and just have it right here, now all of a sudden we have 2 going to a possibility of 4 and 3. If I put in 1, gives me 3. If I put in 7, gives me 1, right? Notice, the only problem we have right now is that every time I put in a number, I know exactly what the output is, except for 2. When I put in 2, there's a possibility that it's going to be 4. But there's also a possibility that it's going to be 3. And that's the violation of a function. Remember, every input must have one specific output. It could have the same output. For example, if I had 2 and it becomes 4, and I had 7 and it becomes 4 again, that's entirely fine because I know exactly if I put in 2, it will give me 4. If I put in 7, it will give me 4. But in this case, the problem is if I put in 2, it's a flip of a coin. Am I going to get 4 or am I going to get 3? No one knows. That's what makes or violates this so that it's not a function. So, which point or points must we remove? Here's the trick. You could either remove 2, 4 or 2, 3. Right? You only have to remove one of them. Because when you remove, for example, 2, 4, you know now when you put in 2, you get 3. Or vice versa. If you remove 2, 3, you know now if you put in 2, you get 4 exactly. The only problem is that these two exist in the same function, right? So one of them has to go away. Once that goes away, this whole set of points is a valid function. Thank you for watching this video. See you in the next one.